Hello everybody, welcome back to another geometry lesson. Today we're going to talk about section 1.4. We're going to start talking about shapes. That's right, it only took us 4 sections in geometry to talk about shapes. So when we talk about shapes, we specifically want to talk about polygons. A polygon is a very specific type of shape. We want to make sure that we are only talking about those during this class, just because if we had to do every single shape, it would be a lot of shapes to handle. We will do circles much later, but for now, let's talk about polygons. A polygon is a closed plane figure. And before I go with the definition, I want to explain what that means. When we say something is a closed plane figure, we are specifically saying that it has an inside and an outside. So like these shapes over here are closed plane figures because it seems like the shape closes up to include some sort of middle space. A lot of these ones over here don't have a closed plane figure because it's not closed. It's an open shape. So the first part of the definition says that this is going to be a closed plane figure. The other part of the definition is that it is formed by three or more line segments. This means that in order to be a polygon, you can't have curved lines, you can only have line segments. The bare minimum is 3. So if we go down here, we can take a look at some types of polygons. A polygon with 3 sides we know is a triangle. A polygon with 4 sides is a quadrilateral. A polygon with 5 is a pentagon. 6 is a hexagon. And we start to notice that there seems to be a bit of a pattern. Triangle, quadrilateral, pentagon, hexagon. These are all Roman prefixes for different numbers. Hept is the prefix for 7. So we have a heptagon. Octa is 8. Nona is 9. Deca is 10. And then after we reach 10, we start sort of recycling that idea of a decagon, but then add a certain number of sides to it. So an undecagon is a decagon plus 1. A dodecagon is a decagon plus 2. And this pattern continues up all the way through every size of shape. I'm not going to have you memorize anything past 12, but I would like you to try your best to memorize all of these names. So for instance, if I was to say, draw a nonagon, well, we would know that it has to be a shape with 9 sides. And remember, it has to be a closed plane figure, and it has to be made of line segments. So as long as there's 9 sides, we can make it happen. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides, right? That is a nonagon. There are many ways to draw a nonagon, but this is just one of them. We would call this shape an irregular shape, though, because it looks like all the line segments are uneven. It sort of looks jagged. If you have a gon, or a polygon, with more than 12 sides, you can just call it an n-gon, where n is the number of sides. So if you had something with, let's say, 52 sides, you can call it a 52-gon. Let's take a look back at our nonagon. In order to actually name this shape, we want to put a bunch of points around it. The points of a polygon are wherever 2 sides meet together. In this case, nonagon will have 9 points. These points have a specific name. They're called vertices. A vertex is just a place where 2 line segments meet. In order to name this nonagon, we need to give each of these points a different name. So I'm going to go around this circle, and I'm going to start giving them letters of the alphabet. A, B, C, D. E will be this one. F, G, H, and I. Easy enough, right? When we decide to name this, we are going to write out, this is nonagon, and then we need to start listing off the points. You can choose wherever you want to start in this shape, but there is one rule. If you start at a point, you have to continue either clockwise through the points or counterclockwise in that order. So if I wanted to, I could start at A and call it nonagon A, B, C, D, E, F, G, H, I. Or I could even start at G and call it nonagon G, F, D, E, D, C, B, A, I, H. That's still a proper way of naming this nonagon because I'm starting at G, going around in one direction, and ending right before G again. I'd like you to pause the video here and try to see if you can draw one of these shapes. We already have a pentagon, a triangle, and a nonagon, so try to draw something different than those three. Draw it, give it points, and name it. Pause the video and try it out now. Hopefully you've had a chance to try this one out. Let's move on. So we have a couple of different types of shapes as well. We have two different ways of defining them. A polygon is called convex if all the lines across the outline are straight and point outwards. What on earth does that mean? Well, a convex shape is one that, when you draw it out, I'll draw it like a quick pentagon here. There we go, pentagon. The idea is, if you were to continue these lines, you would see that none of them touch the inside of the shape. See how if I continue those lines forever, none of them would ever go into the middle of the shape? If the sides don't go in towards the middle of the shape, it is convex. Alternatively, a polygon is concave. Concave if one line is curved inward. If even one is inside, it is no longer convex. I'll give you an example here of another pentagon. 3, 4, 5. There we go. If I drew the lines here, we would see that most of them are good. You know, this one here doesn't go to the inside. This one doesn't go to the inside. This one doesn't go to the inside. But this line, if I continued it, goes into the middle of our shape here. See that little red overhang? And this one here also goes into the middle of our shape. If even one line is curved inward towards the shape, it is concave. An easy way to also think of it is to think about the diagonals of a shape. In a convex polygon, if you draw diagonal lines from every single point to every single other point that's not next to it, you'll get the diagonals of a polygon. So in this shape, the diagonals are cutting through the middle. In this shape over here, it's a 1, 2, 3, 4, 5, 6 hexagon. If I drew all these lines, all of them would be inside the shape. None of them would go outside. If this is true, if all your diagonals are inside the shape, it's convex. But if I tried drawing all the diagonals of, let's say, this middle shape here, we would have some problems. These two are in the middle, these are in the middle, but these are on the outside. So overall, if you are drawing your diagonals, and even one of them goes outside, it's also concave. Concave means it has a little cave, like this shape here. When we talk about two polygons being congruent, we are saying that they have the exact same shape, the exact same size. But how do we determine that? I mean, we could use a ruler, but the best way to determine it is if all the sides are the same length and the angles all have the same measurement. So if we take a look at this shape here, this is quadrilateral CAMP, C-A-M-P. We can see that there's another one, SITE, S-I-T-E. I want to make sure that these are congruent, and I want to find what points are congruent to which points. There's a couple of easy ways to do it. Way number one is to look at the angles. So if you see here, angle C has an angle with one tick mark. Angle S has a tick mark. So C must be congruent to S. Easy enough, right? Another way to do it is to look at the tick marks on the sides around the angles. So on one side of C, there's one tick mark. On the other side of C, there are 4. On one side of S, there's a tick mark. On the other side of S, there are 4. Therefore, C is congruent to S. But the easiest way to tell is by a congruency statement. In a congruency statement, remember that the first point in the first one is congruent to the first point in the second one. The second point is congruent to the second point. The third is congruent to the third. The fourth is congruent to the fourth. Very nice. Let's take a look at area and perimeter now. This is the big one for this section. When we talk about the perimeter of a polygon, we are asking how much material makes up all of its sides added together. So you can add together all the sides of a polygon to find its perimeter. In this figure, we have a 15 centimeter side, 2 5 centimeter sides, and a 12 centimeter side. So all we need to do to find the perimeter, P, is add them together. 15 plus 5 plus 5 plus 12. 15 plus 5 is 20, plus another 5 is 25, plus 12 is 37. So this perimeter would be 37 centimeters. Whenever you're finding the perimeter of a shape, you can always just add up all the side lengths. But we're also going to learn some easier ways of finding perimeters, of common shapes at least. The area is a little bit more difficult to find. The area of a shape is the amount of space it takes up in its middle. Area can be found a lot of different ways, but for the most common shapes, we have some formulas. Formulas that you may have heard before as well. So for a triangle, the area can be found by taking 1/2 times the base times the height. Now, what is the base and what is the height? Let's call this side A, this side B, and this side C. The base of a triangle is whatever side is perpendicular to its height. Now, where's the height? The height of a triangle can be found by starting at a base and drawing a dashed line to the furthest tip of the triangle. This would be the height. So the area is 1/2 times the length of the base times the height. The perimeter, again, is just adding up all the sides. So if I flipped over to the other side, let's see if we can find the area and the perimeter of this triangle. So the area, again, is going to be 1/2 times the base times the height. You can also do the base times the height divided by 2, if that's easier to remember. So when we're looking for the base and the height is always going to be from the furthest vertex to the base. So that means this is the height and this is the base. The base is 9 inches. The height is 5.2 inches. So this becomes 1/2 times 9 times 5.2. Try this one on your calculator, and then we'll come and check back in just about a minute or so. Hopefully we see that the area of this particular triangle is going to equal 23.4. Now, when we're talking about the area of a shape, we have a very special type of unit that we use. We're no longer talking about one-dimensional measurements like how long something is. We're talking about an interior space. It's not enough to say that it's 23.4 inches. We're in the second dimension. To show that we're in 2 dimensions, because this is an area, we put a squared above our unit. 23.4 squared inches. But the perimeter is going to be super easy for this one. Why? Because the perimeter is just adding together all the different sides. 8 plus 9 plus 6. So if we do 8 plus 9, we get 17. Plus 6, we get a perimeter of 23 inches. Let's flip back over and take a look at our formulas again, because I want to talk about rectangles and squares. These are the easiest shapes to find the area and perimeter of, by far. To find the area of a rectangle, all you need to do is multiply together its length and its width. So, let's say the length of this triangle would be here, and the width is here. Or you could flip them around. You could also say the length of the rectangle is here and the width is here. Doesn't matter. What matters is you just have to multiply together 2 sides that share a right angle. And you've got the area. Now the perimeter is interesting because we have a formula. Keep in mind that the perimeter of a shape is found by adding together all the sides. Well, I didn't label some of these sides. All I labeled was that the length and the width are here and here. And I want to give them 2 different types of tick marks because they're different. They don't need to be, but they can be. Do I know how long the other side is across from L? Well, in a rectangle, the opposite sides are the same length. So this is also going to be L. And that means that this side is also going to be W, because in a rectangle, the opposite sides are the same length. That's why to find the perimeter, you could also just do 2 times the length, because you have 2 lengths, plus 2 times the width, because you have 2 widths. For a square, it's even easier. In a square, each side length, S, is the exact same, right? So these are all congruent to each other. Every single side here is congruent to every other side. That means the area of a rectangle, where we would do length times width, gets even easier because it's just side times the second side. It's sides squared. So if I told you that one side of a square was 4, its area is 4 squared, or 16. The perimeter is super easy too because it's all length S. It's all the length of the same side. So since you have 4 of them, the perimeter is just 4 times S. Let's try these out over here. So if we wanted to find the area and the perimeter of this rectangle, remember that the area is length times width. Okay, do we know the length and the width of this rectangle? We do. We know that the length will be 8 and the width will be 10. Or you could think of it as the length is 10, the width is 8. Both are fine. So to solve this one, we just need to do 8 times 10. And since 8 times 10 is 80, this will be 80 yards squared, or 80 square yards. For the perimeter, we just have to do 2 times the length plus 2 times the width, or if you don't want to remember that, just add up each of the sides. The length is 8, so 2 times the length is 16. The width is 10, so 2 times the width is 20, which we know will equal 36 yards. Easy. The square is going to be the quickest one yet, because the area is the length of the side squared. Well, here the sides are all 8, so it's just 8 squared. What is 8 squared? Well, that'll give us 64 square yards. The perimeter is just 4 times the length of the side. So since the length of a side is 8, it's just 4 times 8, which is 32 yards. Fantastic. Let's move on to examples 4 and 5, because things get slightly, let's say, interesting here. I'm going to zoom in on example 4 so we can see. But here's what we've got. We now have a triangle that is on a coordinate grid. I do apologize, the printing can get a little weird with these thin lines, so you might not be able to see them very easily, but I'll help you out. Keep in mind that this grid has a very unique scale. Every 2 squares, it goes over 1. So this is 0, this is -1, this is -2, this would be -3. 0, skip 2, go to 1, skip 2, go to 2, skip 2, go to 3. So just keep in mind the scale for this problem is going to be different than ones we have seen previously. I'll draw it out like this so we can see it a little easier. In order to find the area and perimeter of this triangle, we're still going to use the same formulas, but we need to know some information before we can use it. To find the area, for instance, we need to know the base and the height. With this triangle in particular, though, it's quite easy. We can just count it out because the base and the height are both straight lines. When I say straight, I should say non-diagonal lines. So let's figure out how long the base is. It goes over 1, 2, 3, 4, 5, 6. It goes from -1 to 2. So how far apart are -1 and 2? It goes over 6 squares, but remember the scale is different for this. It is 3 units long. The height is going to be quite tall. This height goes from -2 on the y to 4 on the y. So how far apart are -2 and 4? Those are 6 full spaces apart. Again, because we're counting every 2 spaces as going up by 1. Cool, so we can use the formula. 1/2 times 3 times 6 will give us our area, which we know, 1/2 times 3 times 6. 3 times 6 is 18, divided by 2 is 9. For units, we don't know units, so we use the word units squared. 9 squared units. For the perimeter, we just need to add up all the sides. So we'll add together 3 and 6 and, we actually don't know the length of this third side. There are a couple of ways to find the length of this third side. Anytime you have a diagonal line and you're asked to find the length, you're really asked to find the distance. So we can use the distance formula here. Allow me to jot down first the coordinates of these points so we can use them. Point B is at the location -1, -2. Point A is at the coordinates 2, 4. So again, we can use the distance formula to help us here. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. All we have to do is plug in our x and y values. Since it doesn't matter which order you plug in the x's and the y's, I am going to choose to plug in 2 minus -1, because that seems like it'll be an easier problem for me personally. So this is going to become 2 minus -1 squared. Again, these are both the x values. Plus, I'll plug in 4 minus -2, because that also seems like it'll be easier. 4 minus -2 squared. Well, 2 minus -1 is just 3. So this is the square root of 3 squared. Plus 4 minus -2 is 6. So that'll be 6 squared. We know that 3 squared is going to be 9, and 6 squared is going to be 36. 9 plus 36 is 45. And if we take the square root of 45 in our calculators, we end up getting the following decimal: 6.71. So this is the distance for our final side. Oops, I drew that kind of off. I apologize. 6.71. So if we take together all of these facts, we can add them up to get 3 plus 6 plus 6.71, which is going to equal 15.71 units. All right? There is another way of doing this as well. The other way of doing this is to do a squared plus b squared equals c squared. So when we take these sides, remember that anytime there is a right triangle, you can always use the Pythagorean theorem, a squared plus b squared equals c squared. If we didn't know this side was 6.71, we would basically be left with the problem of 3 squared plus 6 squared. 3 squared plus 6 squared equals c squared. Well, again, 3 squared is 9, 6 squared is 36, so it's the same thing. 9 plus 36 equals c squared. That means that 45 equals c squared. And again, you would just get the square root of 45, which we know is 6.71. So if you have a right triangle, meaning there's a right angle down here, you should always use the Pythagorean theorem. It's a little bit less messy. Last but not least, we want to find the area and perimeter of this rectangle. The area of a rectangle is just the length times the width. So all we need to do is figure out how long it is and how wide it is. The length here we can count out, but again, remember, we have a very unique scale on these diagrams where every 2 spaces moves up 1 number. So the length is 1, 2, 3, 4, 5, 5 units. And the width here is going to be 1, 2, 3, 4, 5, 6. So the area, length times width, is just going to be 5 times 6. 5 times 6 is 30 square units. Remember that the perimeter can be found by taking 2 times the length plus 2 times the width, or you can just add up all the sides. Our length here is 5, so 2 times the length is 10. The width is 6, so 2 times the length is 12. 10 plus 12? 22 units. Very nice. With that, that concludes section 1.4. So thank you so much for listening, and have a fantastic rest of your day.